Right, let's dive into an explainer that completely transforms a famous historical poison into a genuinely fascinating story about modern food science. When most of us hear the word arsenic, our minds immediately jump straight to Agatha Christie novels, vintage murder mysteries, or maybe some dramatic courtroom poisoning. But today, we're going to completely rewrite that narrative. We are stepping out of the realm of fiction and into the very real, very complex world of environmental science and our daily nutrition. Now, this might sound a bit alarming, but to truly grasp this topic, we kind of have to start by asking ourselves a slightly uncomfortable question. Are you eating arsenic literally right now? Well, the short answer, as we're about to see, is almost certainly yes. But hey, before you panic and completely clear out your pantry, you need to understand that the reality of arsenic in our environment is far more nuanced and honestly, far more interesting than a simple yes or no. We're pulling all our insights today straight from this incredibly detailed food safety brief, which was originally put together in 1999 and updated in August 2010. It meticulously outlines the complex realities of arsenic in our environment and our diets. It's really a foundational document that pulls together hard data from major global health authorities like the World Health Organization, just to give us a super clear scientific picture of what we're actually dealing with here. So, here's our agenda for today's explainer. First, beyond the murder mystery. Second, where is arsenic hiding? Third, the tale of two arsenics. Fourth, tracing the health impacts. And finally, setting the safety limits. Let's get right into it.
Section 1. Beyond the murder mystery. Reintroducing arsenic.
Okay, so the absolute most crucial point to get straight is that arsenic isn't just some synthetic chemical concocted in a dark laboratory. It is actually a naturally occurring metalloid, and it's really mobile in our environment, meaning it's constantly shifting around as soluble salts or dust. It's fundamentally baked into the Earth's crust, naturally found in trace amounts in literally all rock, soil, water, and air. You just can't entirely escape it, because it is quite literally part of the planet we live on.
Moving to Section 2. Where is arsenic hiding? Sources and exposure.
So where is all this stuff actually coming from? Well, our exposure comes from a really interesting mix of totally natural geological processes and specific human industrial activities. On the natural side of things, volcanic eruptions are constantly adding to the atmospheric load of arsenic dust. And then on the human side, when we smelt copper or nickel, or when we burn fossil fuels, large amounts of arsenic get released as a byproduct. Also, while its use in agriculture, like in pesticides or as livestock growth promoters, is super heavily restricted today, historically it was quite common. All of this eventually settles right into the soil and water, where plants take it up, sometimes literally confusing it for necessary nutrients like phosphate. Now, this data is absolutely fascinating. There is a dramatic difference in the actual type of arsenic found in our food. If you just test for total arsenic, seafood actually has the highest levels. But look closely at the numbers here. Only a tiny fraction, about 2% in fish and 3.5% in other seafood, is the really dangerous inorganic kind. Meanwhile, things like cereals, rice, and vegetables, they can contain up to 100% of that harmful inorganic arsenic. Which brings us right into Section 3. The tale of two arsenics, a crucial distinction. This contrast right here, it's everything. It's the whole ballgame. Organic arsenic, which mostly hangs out in marine organisms as a compound called arsenobutane, is generally considered by scientists to be of pretty much no toxicological concern. Your body just processes it easily. But on the flip side, inorganic arsenic, which absolutely dominates in drinking water, soil, and crops like rice, is highly toxic. In fact, it is officially recognized as a Group 1 human carcinogen. To really put the sheer danger of that inorganic form into perspective, we have to talk about its acute toxicity. These numbers are incredibly stark, and they represent the literal threshold between life and death. Just 70 to 300 milligrams. That's it. Ingesting just that tiny amount of the specific inorganic compound, usually as arsenic trioxide, is historically known to be fatal to humans. This is that acute toxicity that made it the murder weapon of choice for centuries. It causes massive, severe gastrointestinal damage. But to be clear, acute poisoning like that is super rare today. What global health experts are actually losing sleep over now is what happens when you consume tiny, tiny amounts over a really long period. Let's look closer at that in Section 4, tracing the health impacts, chronic exposure risks. The source details a really wide range of severe, long-term impacts from chronic exposure to an organic arsenic, and it clearly explains why the International Agency for Research on Cancer slaps it with that Group 1 carcinogen label. Beyond significantly increasing the risk for lung, skin, and urinary bladder cancers, chronic ingestion is tied to skin lesions, neurotoxicity, cardiovascular disease, and even diabetes. And perhaps the most concerning part? It's a transplacental carcinogen. That means exposure in utero or during early childhood can significantly increase the risk of a person developing cancers decades later in adult life.
Because of all these risks, something pretty major happened in the regulatory world. Global health authorities actually had to completely throw out their older safety baselines. Previously, they used this thing called a provisional tolerable weekly intake limit, basically a safe weekly dose. But recent data evaluated by the European Food Safety Authority showed that the margin of exposure was simply way too close to actual risk levels. Basically, the microscopic amounts people were just normally consuming in their daily diets were uncomfortably close to the amounts known to cause a 1% increased risk of certain cancers. So, those old safety limits, they were formally withdrawn.
And when we actually break down dietary intake by population, the way exposure varies is vital to understand. An average adult takes in just a tiny fraction of a microgram per kilogram of body weight daily. But notice the stark contrast with infants here. Infants consuming rice-based formulas, especially if they're reconstituted with water containing just average levels of arsenic, face the highest relative exposure by far, sitting at 1.63 micrograms. In general, kids under 3 have dietary exposures 2 to 3 times higher than adults relative to their body weight, largely because of rice-based weaning foods and the fact that they drink more water per pound of body mass. All right, final section, Section 5, setting the safety limits, global regulation, and testing. So how do we actually keep our food and water safe? International bodies step in to enforce extremely precise numerical limits. The World Health Organization, along with regulators in Europe, the USA, and Canada, draws a really hard line at exactly 10 micrograms per liter for drinking water. And the Codex Committee maintains similarly strict limits for everyday staples like natural mineral waters, fats, oils, and even food-grade salt. Monitoring these specific, tiny numbers is exactly what prevents widespread chronic poisoning today. But how do you actually enforce a limit of 10 micrograms? Well, laboratories have to use these incredibly advanced step-by-step analytical methods to separate out and measure that dangerous inorganic stuff. It's not enough to just detect arsenic generally, as we've learned. They absolutely have to know what kind it is. They use methods with wildly complex acronyms like HGAAS for total arsenic, and most importantly, speciation by ICPMS. That speciation is the critical step. It's what differentiates the totally harmless organic arsenic in your fish from the highly toxic inorganic arsenic in your rice. We're going to wrap up this explainer with a super practical, everyday insight straight from the European Food Safety Authority's findings regarding how we prepare our food, and it's all about boiling water. Boiling water does not make arsenic disappear. It literally doesn't evaporate. In fact, if your tap water contains inorganic arsenic, boiling pasta or rice in it means the food actually acts like a sponge, absorbing that arsenic right into the meal before you eat it. So it leaves us with this fascinating, very real-world application of the science to think about every single time we put a pot of water on the stove. I mean, we've journeyed from an ancient murder weapon to a highly complex modern regulatory challenge. Arsenic is just the perfect example of why understanding the nuances of our natural world, like simply knowing the difference between what's organic and inorganic, is absolutely vital for our health. Keep asking questions about what's really in your food, and I will see you in the next explainer.